All right, let's just jump right in. Today we're talking about something called Prometheus, and it has a mission that is, well, pretty bold, to design the self-driving laboratories of the future. The whole idea is to completely change the game for how we discover new materials. But first, we really have to start with this huge, kind of nagging question. We live in this age of exponential tech, right? So why does it still take up to 2 decades to develop and actually commercialize a new material? I mean, just think about that. The phone in your pocket is going to be a museum piece, but a new polymer from medicine or manufacturing, yeah, that's just finally hitting the shelves. It's kind of crazy. And no, that is not an exaggeration. 10 to 20 years, that is a whole generation of lost opportunities for things like better medicines, cleaner energy, and, stronger, lighter products. The process is just way too slow for the kinds of problems we need to solve, like yesterday. So this problem actually has a name. They call it the Edisonian bottleneck. And it's exactly what it sounds like, that old school method of discovery. You know the drill. Hypothesize, synthesize, test, analyze, one painstaking step at a time. It's slow, it's super expensive, and honestly, it relies on a whole lot of intuition and maybe a little bit of luck. Look, that old way of doing things just can't keep up anymore. It's time for something totally new. So Prometheus is here to basically kickstart a new approach, what they call the fourth paradigm of scientific discovery, one that's driven entirely by data and automation. And that solution, of course, is Prometheus. Now, here's the really crucial part to get. Prometheus doesn't just run the experiments. No, it's an AI framework that designs the entire self-driving laboratory from the ground up. We're talking the robotics, the software, the AI, literally everything you'd need to run autonomous experiments 24/7. And what's so interesting here is how the whole process shifts. The old way is what's called open loop. You do a step, and then you wait, and you wait, sometimes for weeks, even months. The new way is closed loop. Think of it like a continuous autonomous flywheel of discovery. The system is always learning, always iterating, and it squashes that cycle from months down to just hours or maybe even minutes. So how in the world does an AI actually design something as complex as a lab? Well, the best way to think about Prometheus is like a project manager who's overseeing an absolute dream team of specialized AI agents. You give it the high-level goal, and this team gets to work, turning that simple requirement into a fully specified, ready-to-build laboratory. And here they are. Here's the team. 9 distinct agents, and each one has an absolutely critical role. You've got your specialists for mechanical systems, for electronics, for fluidics, software, and the core AI. It is a completely comprehensive approach. They've thought of every single aspect of lab design. So, right at the top, you have the orchestrator. It's basically the chief architect breaking down that big vision into smaller, manageable tasks. And working right alongside it is the integrator. Think of this one as the systems captain. Its only job is to make totally sure that the robotics, the software, and all the fluidics connect and talk to each other flawlessly. Then you get the 5 synth agents. These are the builders. MechSynth designs the physical robots on the structure. ElecSynth handles all the power and the wiring. FluidSynth tackles the incredibly tricky challenge of pumping things like really thick polymers. SoftSynth writes all the control code. And then AI-Synth, well, that's the brain. It designs the intelligent part that decides which experiment to run next. And this part is brilliant. It just shows how committed the system is to quality. So you have the validator agent. It runs simulations to prove, hey, this design is actually going to work. But then comes my favorite agent, the adversary. This agent's entire job is to be a professional pessimist. I love it. It just stress tests the design with all these extreme scenarios, like what if the fluids are super thick, or what if equipment fails? It finds those hidden flaws before you even order a single screw. Okay, so letting an AI design a lab that handles real chemicals and real machinery, that raises a pretty obvious question, right? How do you make sure it's safe? Well, the answer is that Prometheus is governed by a set of totally ironclad rules, a foundational document that they call the Constitution. These principles are basically the system's ethical bedrock, and they are in a very strict order of priority. Number 1, the most important one, is human safety primacy. Nothing else matters if that isn't met. Then it's followed by chemical safety, making sure it obeys the laws of physics, and a requirement for transparent reasoning. Safety and reality are just completely non-negotiable. So the crucial point is this, and I'm going to quote this directly from the Constitution because it's so important. These principles cannot be overwritten by any agent, operator, or downstream document. So let's be clear. This isn't just a set of nice guidelines. Nope. It is the absolute, unchangeable law of the system. And to enforce this, the system actually thinks on two different levels. First, it is bound by what are called governing equations. These are the fundamental, can't-be-changed laws of physics. That's what is possible. But it's also guided by design rules, which are just decades of human engineering best practices. That's what is wise. And Prometheus has to respect both. So you see, this isn't just some abstract theoretical concept. Prometheus is designed with a really clear, practical, and achievable plan to actually get this technology into laboratories and start accelerating the future of discovery. And they've laid out this super pragmatic 16-week roadmap to get there. It starts with a frugal twin, a low-cost lab that's perfect for a university or startup team. From there, it scales up to a full production self-driving lab, and then finally to a massive, high-throughput facility for those major industrial challenges. It's built to be accessible from day one. And this is the endgame. This is the vision that ties everything together. Prometheus designs a lab. That lab runs autonomous experiments, which generates tons and tons of high-quality data. That data is then used to create even better AI models, which then allows Prometheus to design an even smarter, faster, more efficient lab the next time. It's a self-improving engine for science itself. Which, brings us right back to that first question we asked, that 10 to 20-year bottleneck. The ultimate promise of Prometheus is to just smash it, completely. So the final thought I'm going to leave you with is this. What kind of breakthroughs in medicine, in energy, in technology? What becomes possible when a decade of research can be done in a single week?